The purpose of this video is to go over question 31 on 3.6, and this question is kind of involved. It's in the type 1 to something that doesn't exist, so does not exist. So we can't deal with this by itself, and the procedure when we have something 1 to the infinity or something that doesn't exist or something like an exponent like this is to take the natural log of the function. So if I have ln, or if I have the limit as x goes to 1 of ln of y, and I want to find the limit as x goes to 1 of y, I'm going to take the left hand side, I'm going to take e to whatever I figure out of the limit of ln of y. So we're going to be able to evaluate this as a number, and then to answer a question for the limit as x goes to 1 of y, our answer is going to be e to that number. So to start, I take let y equal 2 minus x to the power 5 tangent of pi over 2x. So then if I take ln of y, I can write that as 5 tangent of pi over 2x times ln of 2 minus x, right? Because basically I can write the exponent down as a coefficient when I take the natural log of both sides. So now I really want to deal with finding the limit as x goes to 1 of ln of y, and I'm going to write that as the limit as x goes to 1 of 5. In this case, tangent's undefined, so I'm going to write that as sine of pi over 2x over cosine of pi over 2x. And then I also have ln of 2 minus x. If I plug x goes to 1, sine of pi over 2 will go to 1. Ln of 1 goes to 0, and cosine of pi over 2 goes to 0. So this is actually type 0 over 0. And if we have it a type 0 over 0, we can plug L'Hopital's rule in directly, right? So if I do that, if I take L'Hopital's rule, I'm going to take the limit as x goes to 1. I take the derivative of the top. So the derivative of sine is cosine. So I have 5 cosine of pi over 2 x times pi over 2. Alright, because the derivative of the outside evaluated the inside times the derivative of the inside. Hold the second function plus hold the first function. Take the derivative of the second, which in this case is going to be the derivative of ln of 2 minus x, which would be 1 over 2 minus x times minus 1. So this derivative of the numerator. The derivative of the denominator would be minus sine at pi over 2x times pi over 2. So now I can see what's going on. If I plug in x goes to 1, cosine goes to 0, so this whole term here, since cosine is 0, this whole term goes to 0, which is handy there. And then sine pi over 2 goes to 1. And I end up with, just kind of cleaning this up a little bit, the limit as x goes to 1, let's rewrite this as minus 5 sine of pi over 2x over 2 minus x divided by minus pi over 2 sine of pi over 2x. So on top, it goes to 1, or we could cancel the sine of pi over 2x, since that's going to cancel each other. That's fine. On top I have minus 5, 2 minus 1, which is 1, divided by minus pi over 2. So I flip and multiply. I have 5 over 1 times 2 over minus pi, which is going to give me minus 10 over minus pi, which gives me 10 over pi. So the algebra here gets a little tricky with fractions. and flipping and multiplying. But really the calculus step is identifying this is 1 to something that doesn't exist. And to set that up, I'm going to take the natural log of both sides, ln of both sides, simplify my expression to get it in the form 0 over 0 or infinity over infinity, apply L'Hopital's rule, and hopefully be able to simplify something. You could make the jump here that it's 10 over pi. It's harder to see, so to see the algebra, we get 10 over pi. The last step now is we know the limit as x goes to 1 of ln of y is 10 over pi. So to find the limit as x goes to 1 of y would be e to the 10 over pi. So that's our answer there on Wiley. We go to enter that. It's going to be e to the 10 over pi. So I know this is kind of involved, but hopefully it kind of helps to see the steps throughout. And if you have any questions, please let me know.